So today our topic is about the binomial theorem, and before we talk about the binomial theorem, there are a couple of things that we need to take notice. The first is the notation n factorial. So this is denoted by n and then one exclamation mark, and we call this n factorial. And actually what it means is that whatever number this n represents is actually equals to, okay, let's put a number, let's say it's 5. It actually means 5 times 4 times 3 times 2 until 1. So, for example, this is 10, then this would be the multiplication of descending order of the consecutive numbers, like from 10 and then 9 and then 8 and so forth. And n should be a positive integer. So here is another example, example 1. So, for example, it's 3 factorial plus 5 factorial. It actually means 3 times 2 times 1 plus 5 times 4 times 3 and so forth until 1. And when you use a calculator, it adds up to 6 plus 1 to 0, and then the final answer is this one. So actually it's quite a simple thing. Just we need to get familiar with this symbol. And example 2 is 6 factorial divided by 3 factorial. So actually it equals to 6 times 5 times 4 times 3 factorial over 3 factorial. So you would discover in this example actually factorial could be crossed out like when you do it in division. So why is it so? Because for example, let's say this 3 factorial actually it equals to 3 times 2 times 1, and the same as here is also 3 times 2 times 1. So actually we can omit the following numbers we are going to write in the multiplication. We can just simply divide or cross out the factorial sign. So it leaves this number 6 times 5 times 4. That's it, the answer. Example 3. Here is 20 factorial minus 19 factorial divided by 19 factorial. So again, we can write 20 times 19, and originally we can write very long, like up to 1, like times 19 and then times 18 and then times blah 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 up to 1, but there's no need to write in such a way, so we can actually just simply write 20 times 19 factorial minus 19 factorial, and we also discover we can factorize it like as if this is a normal number. Take out the 19 factorial, which is the common factor of this line, and it gives rise to this one, and 19 factorial bracket 20 minus 1, and then the lower side is also 19 factorial. And why is it like this? Again, we can imagine that actually this 19 factorial means we write the multiplication in descending order for consecutive numbers. So actually it means both of these represents the same sequence, like 19 times 18 times 17 times blah 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 up to 1. So again, we can just simplify it by writing this symbol and then cross out, and it gives rise to 19. That's the final answer. Okay, so here is another new notation that we are going to look into. It is called CNR. It can also, because there are two ways in writing this notation, we can write in this way, or this is also called CNR, or some say NG. choose out, but doesn't matter, just see how is the habit. So this is called, for me, I would also call this C and R for simplicity. So actually these two are equal, and what it means is that it actually means this equation, and in order to memorize it more easily, I would suggest that we can use this way, like the upper side is n factorial and then over n minus r factorial and then r factorial. So when we just look at this one, we can already just follow the sequence and memorize the equation at the same time. Like, okay, the upper side is n, and then the lower side is n minus r bracket factorial, and then the final thing is r factorial. So we can look at it later how it can apply to our calculation. And there are two more rules that we can take notice. One is Cn0 actually equals to 1, because you can look into the details. After applying the same equation, it actually means n factorial over n factorial, and it gives rise to 1. Again, Cnn means n factorial over n minus n factorial, and then finally n factorial. So this gives rise to 0. 0 factorial is actually 1. And these two, we can actually cross out and cancel it. So finally, it also equals to 1. So here is an example. For C53, we can go through it quickly because it's already quite clear. C53 is also written in this form, and it can mean 5 factorial over 5 minus 3, 5 minus 3 factorial, and then 3 factorial. So after calculation, the final answer is 10. Because 5, we can write 5 times 4 times 3 times 2 times 1, or in short form, 3 factorial. The lower side is also 3 factorial, so in habit, we would just write up to what shows up in the lower side as the larger number. So we can just simply cross out these two. And this one is obviously 2 times 1. So actually cross out, here is 2. 5 times 2 is 10. It's quite clear. Another example is also not too complicated. Actually, it's quite straightforward. This one actually means this one, so it is clear as well. And C15, 0, we already say that whatever Cn0, it always equals to 1. So this one is 1 plus this thing, and then finally going through the steps, it adds up to 57. When here we have a certain power, and when we expand all the terms, we will discover there is a pattern, like here it is 4. So all these number represented by these brackets would be actually 1, 4, 6, 4, 1. So actually it means like this. It is much clearer. So when power is 0, it gives rise to 1. When the power is 1, is actually a plus b. No need to explain. Here also 1 to 1. When we learn in low forms, the all power 2 means a squared plus 2ab plus b squared. When it comes to cube, also there's a pattern, is 1331. So when the power is 4, before we calculate the CNR thing, we already can have in our hearts this picture. The coefficient would be 14641. before we expand the other things inside each term. So when we come back to this example, we can see that after this line, originally we wrote C40, C41, C42, C43, and C44. Now we can see that it corresponds to the number 14641. So we can either calculate all these brackets by calculator by the factorial equation, or we can know it by heart that for the power 4, it corresponds to a pattern that the number should be 14641. So, knowing this could be more convenient because after we calculate all those C notations, we can double check by heart that it should be consistent like this with the red brackets. And then the final line, only the final coefficients are shown. It actually corresponds to, for example, the first one is 1 times 2 to the power 4 is 16, and the second coefficient is 4 times 2 to the power 3 is 32, and the third coefficient is 6 times 4 is 24, and so forth. So here you can see how it works. So I think it's quite clear for now. So that's all for today.